And we'll add one more to that list too. Let's add HNO2. So what I'd like you to do is rank these acids from weakest to strongest. So the weakest to strongest of these acids here. Okay, so once again, using the data table, you have to use your data table for this here. The one that's lowest down, I guess that's where you want to start, because that'd be the weakest one. Well, let's do that first then, I guess. So H3BO3 is quite low. H2CO3 is higher than it. I'll just sort of show that over here. There's a lot of jumping around and stuff, but it's probably worth it. So there we go. So we had HBO3, H3BO3, sorry. We have H2CO3. We had HNO3, I think. Oh my goodness. Oh, getting old. And HNO3 and HNO2. That's what it was. I kind of confused myself there. So HNO2. So where's HNO2? HNO2. Okay. So remember, the acids go strongest at the top and get weaker as they go down. So we're going to put the bottom one. So let's go back here. So, oh my goodness, getting dizzy. Okay, so the very weakest one would be the H3BO3. The next weakest would be the H2CO3. And then the next weakest would be HNO2. And the strongest, which actually is a strong acid, would be HNO3. So these three over here, they're all weak acids. And this actually is a strong acid here. Okay, so next question here. Here's four compounds, and what I'd like you to do is rank them from the strongest base to the weakest base. So maybe pause the video and take a guess at that. Okay, so from the table, we know that the arrow points downwards. So if we're ranging from strongest, and we're going all the way to the weakest of the bases, then we have to start with the one that's lowest down on the base column side of the table. So the lowest one of these that's on the table would be the carbonate ion. So that's quite basic. The next one here would be the cyanide ion. And then where are we here on this? And then we have we have C2, so the oxalate, O4, 2 minus, and then above that is the HCOO minus. And that's that would be going from the strongest of the bases to the weakest of those bases. So that means the ones over here, this side, they would ionize more than this side would with the water itself here. Okay, so here's another question. So if H3Xe is a stronger acid than HF, write the formula of the conjugate bases of these acids, and then which of those bases would be stronger then if you're comparing those base strengths. So let me pause the video. So if you think about H3Xe, if it's stronger than HF, it would have to be higher up on the table. So I'm going to write it as if it was on the data table. So here's our equilibrium arrows. And so we know that for HF, it makes H plus and F minus. You can find that on the data table. And H3Xe is higher up, so we were told the acid strengths get stronger the higher up you go. And now conjugate bases, well, just remove a proton, I guess. So if we take a proton away, that's going to give us H2Xe minus 1 then, in that case. So, so these, of course, are the acids on this side. These chemicals here are your bases on this side. Now, the acid strength increases as you go up the acid column, but the base strength decreases as you go down on the base column. So although this acid here is stronger than HF, which would be the stronger conjugate base then? So the one lower down is the stronger base, so fluoride would have to be the stronger base here. So fluoride ion would be stronger, would be a stronger base, meaning it would ionize more than H2Xe minus.